Good morning, everyone. First of all, really thank you. We're really excited to be here from SNC-Lavalin. We've spent a lot of time thinking about digital technology and what does that mean? What does the problem look like? How do you even answer it? We read a quote by Albert Einstein that said, if I had an hour to solve a problem, I would spend 55 minutes thinking about it and 5 minutes actually solving it. So for us, we kept thinking that identifying this problem was the real key to it. And we've come up with a bunch of ideas that we think might actually be the secret sauce of how to take everybody to the next level. And for some of you, you may look at this and wonder, well, why would they share this? Why tell everybody your secret sauce? Some of my competitors are in this room. But the reality is we're a pretty small, tight-knit industry. And as an industry, we all need to change. And unless we have some currents of thought that are moving in the same direction, it's going to be really hard to implement those changes. So we thought that we'd come here and we'd share quite a bit about what we think tomorrow could look like and how these projects should be executed. Hopefully you'll be able to get a bunch of value out of that. So digitization means a lot to us, just because it allows me as a project director to deliver flawlessly. And that's what we want to keep doing for our clients. But as we kept thinking about our projects and trying to go through and identify the problem, we've identified there are challenges to adapt. I think you've heard a lot of it spoken about. Greg did a great job of actually categorizing quite a bit of it. As project directors, it's very difficult because I can't make a real-time decision. Secondly, dealing with surprises. You know, Mike Tyson has a great quote. I love it. I use it, sadly, way too much. Everybody's got a plan until you get punched in the mouth. And I look at it and I think about it. It is 100% true in the course of EPC project execution. How are you going to know 3 years before all the effects that are going to impact your project as time goes on? And at SNC-Lavalin, having done projects all around the globe, we've seen a multitude of effects, things you could never have guessed had hit us. And somehow, you've got to find a way to deliver. So your ability to deal with surprises is challenging, and we do it by sheer human effort right now. But we notice that a lot of these elements all end up deriving back to the same problem, the same cause. I'll give a hint. It has to do with something called paper, but we're going to get to that in a little bit, and we're going to talk about how we think there's a smarter way out there. So I'd like to take a minute to try to look at how we've implemented tools in our industry. Because in order to understand where you need to go, it's quite instructive to understand how you first got to where you are today. What I put up on the screen here is one of the original IBM PCs. Anybody have one of these, by the way? You can buy $500 for one of these. Yeah. It's the original IBM PC 5150. It actually came into most offices in the early 80s. And it did a great job of supplementing report writing. So where everybody was typing on typewriters, a PC came in, and you could now cut, paste, delete, and it allowed you to reuse information. So it supplanted a portion of our work. A portion of our work of writing reports or proposals got moved out to a PC that replaced that function. And then, of course, through the 90s, we got more CAD coming in. We started doing a lot more 3D modeling, no more physical models on the desk anymore. But all we were really doing was supplanting a portion of our work that we did by paper. Instead of having a CAD room, we now had a PC. And we haven't really made a whole lot of changes. And then if you walked in today, of course, you saw the really exciting virtual reality work in the back. But if you take a second to think about it, this is a very, very different tool. Because we never had this problem. I never had a problem in the 80s of how do I look at my system in virtual reality. It wasn't even a thought process. We would look at the drawing and you would imagine what the plant looked like and you would know what the plant looked like when it was finally built. So all of a sudden we've had solutions come out that started solving problems we didn't even know we were there. But what do they really do? They're helping us become more in touch with our data. They're helping us actually start to feel our data. When I start thinking about digital, I think about it, well, we use lots of computers every day. We've got lots of data being created. Digital for us actually means the ability to apply infinite computing power to a problem. I can now brute force solve a problem. But my ability to apply infinite computing power today in our projects is quite limited. So we kept thinking about this, and we kind of worked through 3 areas. We started thinking about what are the tools that we have. And we very quickly realized tools aren't the problem. In fact, there are a lot of tools available, and hats off to the AVEVA team. I mean, they know me and they know what I think of their products. Excellent tools right there. But AVEVA's not the only provider that's providing great ideas. You're seeing lots of tools come up through the industry, and multiple other vendors are here as well. So tools aren't the issue in terms of EPC execution. Maybe it's got something to do with the way we execute projects. Maybe it's something about the way that execution is done that just does not fit. You know, I was talking to one of our strategy people yesterday, and I was saying that sometimes I'm running a project and it feels very much like playing golf in a suit. I can do it. Well, okay, first of all, my original golf game's not very good, but in a suit, it's even worse. You can do it, but there's something holding you back. You don't have the ability to perform. You can't ask a question and get an answer very quickly. And the question is, why does it not feel right? Secondly, if you're engineers in the EPC world, many in oil and gas will complain to you that they don't get a chance to really be creative. What makes it even more challenging as a project director, I'm very interested in what the cost and schedule look like for my projects. And I would like everybody in my team to be thinking about the same thing. But in many ways, we're not. In many ways, the engineering teams are given a segment of work they got to look at. They're given a small piece to look at, and they're expected to progress that small piece. And they're not getting a vision for what the overall outcome needs to look like. So I, as the project director, am trying to piece this together and trying to keep asking questions on what that should look like. And then lastly, machine learning. Now, we hear about this all the time, and I'll do a little bit of explanation later on about machine learning if you don't know a lot about it. It's really not that complicated. But machine learning is a great way to be able to implement lessons learned into your project. And it's being done without having to invest a whole lot of time and energy. It's actually being done very simply. And I'll get into a bit of an example. So we've been doing quite a bit how to rethink our execution, especially in the way of setting ourselves up to allow for machine learning to happen. And I'm going to share a lot of that with you guys today. Now, I've started alluding to this, but I guess one of the original questions you need to ask is, what makes great projects? And think about it for a minute. All the projects you've been on, anything you've done, including a home renovation, what makes great projects? It's not always the tools you have. It's not always the equipment you have. It's the people. And it's your people that make great projects. We like to look at it when everybody comes in to work on my projects, no one gets up and do a bad job. Yet mistakes happen. How did they happen? Well, something happens between the time the person comes in, turns on their computer, gets their coffee, and starts doing their work, that something that we do in our systems and our execution gets in the way from them being great. So how do I start clearing the path of execution to allow people to be great? How do I allow them to ask questions? We looked at how do engineers even come into engineering in the first place? Naturally, engineers are problem solvers. They naturally ask questions. They're naturally inquisitive. And more importantly, they naturally want to try stuff. But if you come into an EPC execution project, we make it really difficult for that to happen. We follow very much a waterfall approach where you start off with a piece of work, that piece of work moves down, and it keeps moving through a cascading system, and you never go back up the waterfall. How is it great to be an engineer then today in oil and gas? How is it motivating to want to go and try something different and provide value? So in order to look at what something could look like for tomorrow, we believe you have to look at a way to allow your engineers to be more creative, to give them the space to be able to make mistakes and try out an idea to see if it worked or not. And you also need to find a way so that your team has a unified vision and goal. So it's one thing for the project director to have a unified goal on cost and schedule. It's another thing for your engineers to be worried about just getting their deliverables out because they're being measured by whether or not they issued their documents on time. There needs to be something done here that helps align everybody in this kind of new framework. So we started looking at, well, what actually happens on our project? And you can see my great little engineer over here. And they do their work, and they produce a bunch of documents. And we all know this, and we belabored this quite a bit throughout the conference as well. And we start, as a PM, trying to figure out where we are in that project, so we start counting the documents and track our progress. But what's on the documents? Well, it's actually data that's on the documents. And that data makes up our knowledge base, and we end up showing progress. But I've personally had to explain to multiple clients why we were behind schedule at a period and then ahead of schedule later on, or vice versa. And in many times, it was because we issued a document that had maybe a hold, but a hold on a very vital piece of equipment. In fact, a hold on something that actually cascaded throughout the rest of the project. So how good was my progressing then? I was really just counting documents. But don't worry, we got computers now, so things have changed entirely. We got a PC that came into the place, and we've got a much smarter way of doing it. And so we brought the computer along, we brought database along, and all we did is we put information into the database, have the database pop out drawings, and we once again count the drawings. The trouble here is the progress that we show is really latent. It's not real time. Because an engineer put some information into a database. They did it on day one. New information got added as time went on. Somebody said, okay, we should issue a drawing, so we issue the drawing. And the time that person put in the data and the time the drawing actually shows up and the progress shows up, quite a bit of time goes by. It's also really hard to determine what the root cause is. What's holding me back from issuing a bunch of documents? Better yet, why am I showing ahead of progress? So perhaps a smarter thing to do is just rethink the whole thing in the beginning. Engineers put information into databases. Why don't I just count the database to track progress? If I did that, I'd have real-time progress. I'd actually know when a problem happened. Better yet, I would know on a daily basis where I was. I would know that if the day after New Year's Day, we were very productive or not. Because right now, we kind of guess at what happens over the Christmas holidays. I would know whether or not a big winter storm in Calgary impacted our ability to progress work that week. I would know it on a daily basis because I would be able to see the database being tracked in real time. And better yet, I can sit in front of my client and show them the database being tracked in real time. Now, I'm not saying don't produce documents. Documents are handy. It helps give you a visual representation of what's out there. I'm just saying, let's issue the documents perhaps at the end of the engineering cycle. And maybe, if we as an industry can make an entire change, we can get rid of all the documents altogether. But it's one thing to talk very abstractly about, let's track the database. Now, what's in that database? How do you track it? What are you going to look at? We started thinking about this, and it's funny, we kept looking over at computer science and what's happening today in the .com world and how things are being done. And actually, this is really easy to do. And it's kind of convenient that I'm at the AVEVA conference because it makes a lot of sense to really just track objects. So why don't I think about everything in my plant, everything that sits in the database as an object? And an object has properties. And I've given some examples here. Perhaps process goes in and puts in their parameters and values, and mechanical will go in and put their items and values, and piping will actually lay out the object, and you'll start getting latitude and longitude where it is. And so you can actually start putting some interesting things in, like cost. And I'm going to come back to cost, but think about cost being one of the elements that you actually have in your object. And now if I want to track my progress, I can track process to see how much of the process data they've entered. And I should see process data going in first, and then I should see mechanical data coming in behind it, and piping and the like, and I should see a nice cascaded movement of information. I just wanted to show you a representation of actually looking at that data and trying to separate it out. In this case, you would end up saying that if those boxes represent all the process information per object, we would be about 23% complete of the process information required for the project, right? It'd be actually a much simpler way of looking at how we're doing things. Now, when you think about progress in the database this way, you've actually broken apart the discipline silos that normally make up our projects. Our teams now are focused on progressing a database. They're not focused on issuing documents. So something's all of a sudden fundamentally changed there. And when you think about the way we do our work today, we're broken down into discipline silos. We're broken down in an org structure that looks very similar to this. And so every discipline is incentivized to work within their core discipline. They're working hard to help make sure they get their process documents out, to get their mechanical documents out, piping and so forth. But I, as a project manager, and it shouldn't just be me, it should be the entire team, is concerned about the whole picture. How do I get the whole picture out? How do I end up engineering the whole project? Now, this process, this org structure made a lot of sense. It made a lot of sense prior to the way we do our work today with computers, because we would issue documents, and a document would come out from process and then cascade and cause other disciplines to do documents, and I could show you a big schedule here instead of a little graphical representation. But the idea is that we set up our schedules to progress the documents, and each discipline then gets a copy of it and can issue 2 or 3 documents. We kind of go down the cascading process. And we schedule our work and we schedule our teams accordingly for that. But in most times, the downstream disciplines don't actually need all the information that's on that document. So how do we end up executing this? How do we end up thinking about having a database-centric way of executing, but we have this organizational structure that causes these different silos? Well, the only answer we could come up with was, you actually have to change it all together. You have to rethink your group. Now, I like to call these teams pods. And the idea is that you put all your disciplines that are required for a certain pod around focusing on completing and progressing a certain area of the database. So you would give a team a certain geographical location. You would give them a bit of a schedule and when they need to get something done. They would then work to progressing that element. And they would sit all very close to each other. But you'd also give them another variable. You would give them cost. Now, this is really hard to do, you would say. Well, how do you get a bunch of engineers to design something and still know what the cost is? Well, I don't need to have the exact cost. I don't need to have the actual PO value that came from the vendor. I need indicative cost. I need to know that one type of heat exchanger is a little bit more expensive than the other type of heat exchanger. So if I have some representative costs in the database against each one of those objects, and I have a unit rate, say, for each one of my, or a unit rate for each one of my pieces of pipe or electrical cable, I can actually do a summation for the area and take a look at what that cost looks like. I can get a very good picture now of what the area is going to be. And better yet, I can do it all in real time. Now, you might tell me this is futuristic, by the way, that the stuff you're talking about, whoa, Rashad, this is crazy. How can you do that? Well, I'm happy to tell you that we actually did this in Calgary with the help of the AVEVA team. And it was fantastic. We were able to put a P&ID up on the screen. Engineers were able to add elements to their P&ID and hit a button and get an estimated cost for what the P&ID was. And really, that was just a summation of all the equipment on the drawing. But you could load up the piping model, look at a view, and hit a button, and get a price for what that entire area looks like, what the entire price looks like. And that's taking the commodity price for each element. Now, how do you control all this? We've looked at it and said, you'd end up having all your pods report to an engineering manager. Now, incidentally, we take a step away and we just kind of think about this for a second. What I'm arguing for the pod is actually being done right now. When you look at very small projects, small project teams of 5, 7, 8 people, they already operate like this. I worked in a small company for a little while. A few of my colleagues are here today from that company. When we were there, we didn't really worry too much about the procedure steps required to go from item to item. We looked at the project and said, this is what we got to do, and we progress the database accordingly, and we'd work collaboratively with each other to help work through and progress the database. And we would push the drawings out because the clients required it, but we were effectively working like this. You can never think about this for a mega project, though. How do I organize a team like this? Except that you now have infinite computing power. You now have the ability to interrogate that database in real time and see where each one of your teams are at. So as a project director, I could quite conceivably have 30 teams reporting to me. That means that I, as a leader, would have to walk by and see 5 teams a day. So if I spent 1 hour, 6 teams a day. So if I spend 1 hour with each team for 6 hours of my day to see how their progress was going and be the leader I need to be to help eliminate boundaries for them, eliminate obstacles, you can imagine a scenario where our teams are actually very compelled to try to do more. You could see a scenario where they could have a great idea and believe and know they now have direct access to the overall leader of the project. You would actually change the way our people interact in our projects. Now, what I'm talking about, once again, is a little archaic, actually. Because if you look at the software industry in Silicon Valley, this is how they do it. It's called team-based structures. And when you talk about how Google and others are progressing so quickly, they do that by setting up small teams that all work together and collaborate together, and the overall project manager is actually just interrogating the database to see where they are and help removing obstacles. So this is easily possible. So if we start thinking down the software route, well, how do these big companies get stuff out? You start coming up with how do they also manage their projects? And how can we actually learn from that? Now, some of you may have heard the concept of called agile. The idea is that basically you work in sprints in software development. So you would do a sprint, which is represented by the first circle. You would then take a look at what you have. You'd work with the client, take a look at it. You'd go through another sprint, get some feedback, do another sprint, get some feedback, do another sprint, get some feedback. If you worked in small teams, could you not do this? Could you not take an area of the plant, a small area of the plant, given to 7, 8 engineers to work on, allow them to work in a design sprint that says, listen, we just want to get a model layout done and get a kind of general idea what this construction costs are going to look like for us to build this. And then we'll come back and we'll keep filling in and maturing the data. You can imagine a scenario now where each one of your pods run through a design sprint. And then we get a chance as leaders to take a look at it and say, yeah, I can see how we can construct that. No, you know what? Maybe we could do a little more savings if we could bring these things closer. This is a little bit troublesome if these items are too close because we can't get this in this way. Maybe we can move it a little further back. And we can start actually allowing our engineers to be engineers again. We can allow them to be creative and come up with ideas and run through these multiple design sprints. Now, some of you might look at this and think, once again, this is, whoa, this is crazy stuff. What happens if I go through a design sprint and I don't like what I did? You know, it's quite possible you might have an idea and get a comment from a construction guy of this is a better way to do it, and then you try to go do it, and it doesn't work. Now, traditionally in our projects, well, we would just try to find a way to fix it and keep going, I guess, right? Because we can't really go backwards all that much. But software and infinite computing power saved this for us. If you took your database and just imagine that it was taken as a snapshot, and you started tracking your snapshots in time, so every day I had a snapshot of my database, I could all of a sudden sit here today, and let's call it the end of a design sprint, you could actually take a branch off of it. And now the top stream is your branch. And you're taking a look at that design, which is a snapshot of where it was the day before. And you progress that design and take a look and say, well, yeah, does this work? Is this what you were after? Are we getting the right cost? Better yet, all the hours I spent in doing this, all the extra equipment that might be required to make this happen, or less equipment that might be required to make it happen, is all in the database. So I can actually get a real-time cost for this change order now. Right? I'm not having to guess of what the consequential effects are by having an issue or making a change to a P&ID. And then it turns out that, you know what, this is a great idea. We should use it. Well, you can merge this then right back into the database. and it becomes part of your main branch. This isn't revolutionary, by the way, because once again, we managed to do some of this work with AVEVA in Calgary, where we tried taking a branch off, making changes, looked at a model and said, what if we change the layout a little bit? Could we save a bit of money? Did an estimated cost, saw the design was cheaper, and then merged it back into the main branch. We're now unlocking the opportunity for us to start thinking differently in the way we execute our projects. But machine learning is about taking the knowledge that you have from everything you've done before, really the lessons learned that you've had in the past, and putting it into the present, and allow you to predict what future outcomes are going to look like. So, has some of you seen any of this neural network? Hopefully it looks kind of crazy. It's actually not as scary as it looks like. All you need to know for our conversation, if you want to become a machine learning expert 101, is you take data that you have, you put it through your layers, through the input layer, stuff happens in the hidden layer, and you have an output. And what you're doing by running your training data through here is you're just training that hidden layer. And what's in each one of those nodes is a bunch of, let's call it simple algorithms, addition, subtracting. We can get a little more complicated. That's the art of the machine design engineer's job to do, to help figure out how to train that. But all we really need to know is, I need a captive data set. But more importantly, I need a structured captive data set. So if you send me a bunch of data sheets from every different engineering contractor in the world, and they were all in Excel, that would not help me. Because the data is not structured in a way that I can easily pull it off and use it for this. But if I save the data in database objects, and internally, say in the SNC-Lavalin group, we saved all our data elements as objects, I now have a structured data set I can use for machine learning. So if you think about that object, maybe that object there was a pump, and all these other colored objects that are coming in are all the different pumps I've taken from all the other projects we've ever done. We can now actually run that through our training model and come up with a predictive machine learning algorithm to figure out what some elements of those pumps might be. Now, some of you might be thinking, well, why? I mean, every project's a little bit different. Why would you do that? I don't really get it. Well, what if you imagine we had this machine learning algorithm set up, and I took something like a heat exchanger, and you have an engineer who picks a heat exchanger and puts it onto their drawing, and as soon as they do that and they hook up the inlet and outlet, the machine learning is going back and guessing what perhaps the dimensions could be, what the weight could be, and what the cost could look like from previous projects. Now, it's not talking about the internals of the heat exchanger. It's just giving you some gross parameters, which gives you enough information for your piping designer to get started and start looking at how they're going to manage their layout, because they have an idea now of the size of the piece of that equipment. It allows your structural team to get some idea of what they need to do in terms of structural design for the weight to accommodate that unit. And if you're building modules where you need to manage center of gravity, this gives you a very good idea then very quickly of what weights I'm putting into the module and which elements should be moved where, so I can manage center of gravity a lot better. And the best part is, it can give you an idea of what the cost is based on all the other projects you've done. Now, I'm not saying that it's going to be 100% accurate. I'm just saying it's going to give you a much better guess. What's more, it also allows you to do quality checking in real time. Well, wouldn't it be interesting then for your engineer to leverage the lessons that they have gleaned off all the other engineers around the world who've worked on the exact same commodity? So when they put an element into a data cell, the AI algorithm is checking and saying, 95% of the time the number is actually this, not that. Are you sure? You now have a way to help train young engineers on all the knowledge from all your other previous engineers. I'm not suggesting for a minute that machine learning would actually start engineering chemical processing plants, perhaps one day. But for now, what I'm saying is that it can help augment our engineering process and allow us to work a lot smarter and faster. So I've gone through a few things with you. We've talked about changing the execution process. We've talked about setting up our teams differently. We've talked about perhaps not using deliverables as markers in between parts of the project. Well, we end up with a bit of a problem then. How do I start to interact with my data? Because traditionally, I'm used to pulling a P&ID out and taking a look at it. I'm used to pulling a plot plan out and taking a look at it. Well, all of a sudden, all the tools we started seeing around us, the virtual reality we saw out in the hallway, the new tools that are coming up around us, all allow us to start interacting with our data in a different way than we're used to. And once you start removing that dependence upon the piece of paper, you now allow your ability to start rethinking how things could occur for you. So as a project manager, I would love to be able to now start walking through my model, not looking at color coding based on what process unit it is, but looking at color coding based on percentage completion. Because I'm very interested in physical stuff that needs to get moved to site and erected and installed. And the bigger it is, the more worried I am. So if I was to walk through a plant and visually see it, now you could say, well, yeah, you could interrogate the data perhaps. You can do a query, and I'm actually quite good at doing queries. And you could find it, but it wouldn't mean as much to you as it would using virtual reality, walking through your plant and very quickly getting a feel for how quickly are we progressing something? How can I feel where I am in the project? What I've been trying to hopefully express to you today is that we've worked on focusing on developing objects within a database and progressing objects, that you can then track progress by looking at the database completion. You can then organize your teams around developing the database, which is then in line with the overall cost and schedule of the project. You can actually now start creating the space for iterations, the space for people to make mistakes and try out a better way of doing something and see if they can pull it off. And then you can set yourself up very easily to use your object data for machine learning. Well, we really appreciate you taking the time today to listen to us. My apologies for going over schedule. Thanks, everyone.